recording. All right. Now, eyes and ears towards the board. I've already got the video with the notes for this already, so I'm not going to delete this out and write it again. I'm going to do this example, so you can find some space to write it down, but it should be similar to the notes that you have as well. But let's do example 12. Up here it says, constructing a tree diagram for multi-stage experiments. Now, what do they mean by multi-stage experiments? All they're trying to say is when you get a problem, and a probability problem where there's multiple steps involved. For example, if I rolled a dice and I said, what's the chance of getting a 6? Everyone here can say, oh, it's 1 6, because there's only 1 6 out of the 6 options. So that's one step, because I only rolled it once. But what happens if I rolled the dice twice and then I flipped a coin? What's the chances of getting at least an even number in tails? That makes it a bit harder. See, whereas I said just one step, that was easy. But if I said, what's the chance of you getting, if you rolled twice, you roll twice, and then I want you to get a tails. So I want an even, and then a tails. What's the chance of getting that? So that becomes a bit more difficult. You can all do it in your head, technically, but there has to be systematic ways. And the tree diagram is one of the systematic ways, along with Venn diagrams and two-way tables. So that's what this exercise is to help you use a tool to figure out that problem. So let's have a look at this multi-step. You got two boxes. You got box A and box B. Okay, so box A they both contain what? Box A and B contains 4 counters each. So we know that there's a total of 4 counters. Box A, which I'm going to draw out so you can see, box A has 2 red and 2 green. So I'd say, all right, 2 reds, 2 greens. That makes up 4 counters there. Box B, on the other hand, it has 1 red and then 3 greens. So those are my 2 options at the moment. So depending on which box you pick, you could get different amount of chances of getting a red and different chances of getting a green. Now they tell you that a box is chosen at random. So you're going to randomly choose a box first. So randomly choose a box. And then, so it says, and then a single counter is selected. So you're going to pick a box first. You could have picked an A. You could have picked B. We don't know which one you picked first. Then your second step is that you're going to pick out a counter. So you can get a red, you can get a green. So how we do this is we illustrate this in a diagram, which we use tree diagram, to visualize it. Here we go. First thing you're going to pick is a box. So which box are you going to pick? Well, you got either option A, option B. What are the chances of picking box A or box B? Yeah, it's 50%. You only got 2 boxes there, and you can either choose A or B. So it's only 1 out of 2 chance to pick A or B. Then after you pick a box, say you pick box A, we know that you can either have, what are the options? What can you pick out when you pick out a counter? What are the options? Red or green. So it's either red or green. Well, if you picked box A, what's the chances of you picking a red counter? Half, because there were 4 counters in total, and there's only 2 that is red. So you get 2 reds out of the 4 counters, which is half a chance, or you can get 2 out of the 4 counters that is green. What I'm doing at the moment is I'm drawing out a tree diagram in a multi-step problem. So first you're going to pick a box, and then next you pick a counter from that box. So here we go. We'll do the same thing for box B. Options are, again, you can get a red or you can get a green. Chances of getting a red. What's the chance of getting a red in box B? Tig.
Box B, so there's 1 red, so it's 1 out of, is that 3, G?
Yes, that's 3G. 1 out of 4, that is correct. So you got 1 out of 4 chance of getting a red, and then Max, what's the chance of getting a green? 3/4, 3 out of 4. There are 3 greens out of the 4. Okay, so now I've drawn my tree diagram. I've got the chances there. Then this is now answering the question. Once you've got that, it's easier to answer the questions. Question A. It asks you, if you picked box A, so box A was chosen, what is the probability that a red counter is chosen from it? Okay, now be careful here. The question is not asking what is the probability of selecting box B and a red counter. See the difference between question A and question D? See, question A includes the chances of getting B, but in question D is there's a chance of you getting B first and then the chance of you getting a red counter. But in A, can you already tell that they said box A is chosen? So you already know that. There is no chances of you getting B. It's 100% that you got A. Now they're asking, what's the chances of getting a red counter? See the difference between the two? So those who are doing methods, that's probably one of the general hardest things that the year 12s and year 11s have to distinguish between. The language that they ask. Are they asking for a chance of getting a B and then getting a counter? Or are they saying, what's the chance of just getting the counter? Okay, in this case here, in part A, they're saying that I know I've got A. What's the chance of getting a red counter? So answering that question, if you already know you got A, so you already know you got this, that's 100% sure. What's the chance of you getting a red then? What's the answer for A? So probability of getting a red, what would it be? Not 2 out of 8. It's actually 2 out of 4. Because remember, it's not out of, you don't have box B. They already told you if box A is chosen. So they already eliminated half of your options there. They said, you've got box A. What's the chances of getting a red counter? So if you only got box A, there's only 4 counters of box A. Chance of getting red is 2 out of the 4. Hence the answer is half. See the language? Language difference? Whereas if I did D, I'm just going to jump down and do question D so you can see the difference between them. D says, what is the probability of selecting box B and a red counter? See, now this is different. This one's saying, I want you to tell me what's the chance of getting B first. And then I want you to get a red counter. Okay, so if you were to do this, now let's do it slowly. What's the chances of getting B first? What's the chance of getting B? You got a half a chance. Yeah, so look at the tree diagram. You got half a chance. So you write down, you got 50% chance of getting box B. And then you're saying, what's the chance of getting a red? You're following the tree diagram. You're going there. Now, the chance of getting a red is 1/4. So what you're saying is you got 25% of the 50% chance. Get me? So you got 50% chance of getting a box B, but then 25% of that 50% is what your chances are to get a red. Okay, so when you say, what's 25% of 50%? That's the same thing as saying 1/4 times a half. That's why we multiply them when we go along the branches. Okay, because we're saying 25% of the 50% chance, so you're actually multiplying them together. So you're multiplying these two. So those who got confused in my language, I'm saying 1/4 times a half will give you the answer. In this case, it is 1 on 8 as a chance. That's your chances for part D when they ask you, what is the probability of selecting box B? Well, you got 50%. And then what's the chance of then choosing a red counter? Well, you're meant to have 25% of that. So 25% of 50% is 1/8. Okay, so there we go. That's part D. That's the difference between A and D. Now let's answer the other questions, B and C. Let's have a look at B. B says, if box B is chosen, what's the probability of choosing a red counter? Looking at the diagram, if box B is chosen, what's the chances of choosing a red counter? Let's go, Derek. What's the chances of getting a red counter if you chose box B? 1/4. That's what you're actually doing. You're actually saying, if you knew you chose B already, what's the chances of getting R? Now notice my notation for those who aren't sure what that vertical line is. While I was away, what's that vertical line represent again? Given. This is conditional probability. So even though it didn't say it to you, that's what they're implying. They're saying, given that you already know you got A, what's the chance of getting red from A? Second part is, if you knew that you already got B, what's the chance of getting red from B? That's why it's a given. Okay, it's a given fact. It's a given knowledge that we have. Let's do C. C is asking, represent the options available in the tree. Oh, we already did that. C is over here. And then D we just did. And E, let's have a look. Now E is asking, what's the probability of getting a red counter? See a difference in my notation? In my notation, over here, I had given that A was chosen, given that B was chosen, This one was getting B first and then getting a red counter. Here, I'm just saying, what's the chance of getting a red counter overall? How would you calculate that, Molly? Oh, yeah. Let's go. You can go. What's the chance of getting a red? How do we do this? Anyone have a crack? How do we find the probability of getting a red counter? Sash, what do you think? Ooh, you're so close. So yes, there are two options. So the question is asking for a red, right? But remember, they're not asking whether it has to be A or there has to be B. So there's two options here. You can get a red from box A. So that's one possibility there. But then you can also get a red from box B. So these are the two branches that are possible. Now, if you worked out the possibility of getting this, what's the probability of getting that? Well, the probability of getting box A and a red counter, the probability is equal to half times half, or 2/4. 2/4 is half. Sorry, Ed?
I was going to say, when you put all like the total possibilities, sorry, the total reds over total possibilities.
You could. Yes, you could do that. The problem is because this is in chances, it's out 1/4, 1/2. If it was counting, then what you're saying is correct. But because it's not a countable thing, it's a chance thing, then you have to work out probability of that plus the probability of this. Okay, but otherwise what you're saying is correct. If you could find how many counters fit here, how many options, and how many options here, and have all the total options, then you're right. That would be the answer. Yeah. In fact, that's called counting methods in Year 11 methods and Spec. They call it counting methods. It's a topic where you do a lot of counting, different ways of counting that. Yeah. All right, and your last one here, that's probability of B and getting a red, which we already calculated before, was 1/8. So together, what's the chance of getting a red? Well, you've got 1/4 plus 1/8, and that gives you 2/8 plus 1/8, and in total, you get 3/8. So I reckon the last one was the trickiest question for you to understand. When they're asking for red without which box to choose, you have to look out all the possibilities of getting a red, and that's your two different possibilities there. Now, I don't want you to do F unless you've done A, B, C, or the prior examples. If you haven't done it, this could be confusing. So I'll need you to work on the previous exercise, but that's today's exercise. For my notes, I already got a video on this for other examples for you to practice. Okay? But that's today. That's the power of using a tree diagram. It's currently 10:47. It is your time now. I'm going to stop the video. I'll come around just to check out where you're